Now let us continue with the last step, that is 5 pi by 3 can be split into 2 pi minus pi by 3. Here also sin 2 pi minus pi by 3 becomes cos 2 pi minus pi by 3. Cos 2 pi minus theta is cos theta, sin 2 pi minus theta is minus sin theta. Therefore this root becomes cos pi by 3 minus I sin pi by 3, okay, which is the complex conjugate of our first root. This is plus, this is minus only. First root is this, third root is just instead of plus there is minus. Okay, these are the three roots of we are getting from first equation. Okay, now we have to, similar way we have to solve this equation, x raised to 5 plus 1. Start with that. X raised to 5 plus 1 is equal to 0. Take my plus 1 on that side, we get x raised to 5 is equal to minus 1, and x is equal to minus 1 raised to 1 by 5, taking 1 by 5 on both sides to cancel this in dash 5. Now again start with minus 1 instead of like earlier step. Here minus 1, start with this, the steps are same for minus 1 cos pi plus I sin pi, and add 2k pi plus pi, again 2k pi, take pi common, and now then take 1 by 5 to the angle using De Moivre's theorem. Now here total 5 roots we want, therefore k start from 0, 1, 2, 3 up to 4, total 5 number we want. Okay, now start putting values of k in the equation to get 5 roots. Now start with put k is equal to 0. Here we get first. Now in this example we want 8 root, out of that 3 root we get earlier. Now therefore here we have to start x4, fourth root. Therefore fourth root becomes k, put k is equal to 0, we get cos pi by 5 plus I sin pi by 5. Put k is equal to 1, we get x fifth root, cos 2k, 2 plus 1, 3 pi by 5 plus I sin 3 pi by 5. Total we want 5 roots. Now middle line is this. In 5 root, middle line is on third root. Therefore till third root we don't need this splitting. Okay, now put k is equal to 2, we get sixth root as cos 2 to the 4 plus 1, that is 5 by 5 gets cancelled, cos pi plus I sin pi. Okay, now after that we want the splitting of the angle. Okay, now put k is equal to 3, we get 3 to the 6 plus 1, 7 pi by 5 plus I sin 7 pi by 5. Now again 7 pi by 5 split into 2 pi minus 3 pi by 5, right? Just cross multiply, 5 to the 10 minus 3. Okay, that is 7 pi by 5 plus I sin 2 pi minus 3 pi by 5. Cos 2 pi minus theta is cos theta, sin 2 pi minus theta is minus sin theta. Okay, this is the same root but opposite in sign, that is complex conjugate of this root. Now put last k is equal to 4, we get 4 to the 8 plus 1, 9 pi by 5. 9 pi by 5 plus I sin 9 pi by 5. Now split this again, 9 pi by 5 as 2 pi minus pi by 5. 5 to the 10 minus 1, that is 9 pi by 5. Same angle for sine. 2 pi minus theta is cos theta. Sin 2 pi minus theta is minus sine this pi by 5. This is the same angle like this, but this root is opposite of this root, complex conjugate of this two. Okay, after half root, the remaining half are the complex conjugates. Not all, in all examples we need to check this example in each example. Okay, these are the 5 roots we are getting, and earlier are the 3 roots. Total 8 root we are getting of this equation. Okay, let us start next. Let us solve the next equation. X raised to 6 minus I is equal to 0. Now I is there. This is very easy example. X raised to 6 minus I is equal to 0. Given equation, take minus I on that side, it becomes plus I. Take sixth root on both sides. We get x is equal to I raised to 1 by 6. Now in the note, what is I value we have to put? Instead of I, we want now cos pi by 2 plus I sin pi by 2. Okay. Therefore put I is equal to cos pi by 2 plus I sin pi by 2 identity raised to 1 by 6. Now add 2k pi to the angle here also raised to 1 by 6. And k value start from total 6 root we want. Therefore one number less than 6, that is 5. 0, 1, 2, 3, 4, 5. Now take 1 by 6 inside. Before that just cross multiply. We get, or take pi first outside to the bracket. We get 2k plus half into pi. 2k plus half, same angle for sine, into pi raised to 1 by 6. Now cross multiply. We get 2 to the 4k plus 1 upon 2 pi. 4k plus 1 upon 2 pi. Now take 1 by 6 inside to the angle. We get 2k 4k plus 1 upon 12 plus I sin 4k plus 1 upon 12 pi. And k value start from same 0, 1, 2 up to 5. Okay, start putting on the values of k. We get 6 roots. Start with k is equal to 0. We get first root as x1. We get cos pi by 12 plus I sin pi by 12. Second root, put k is equal to 1. We get 4 plus 1, 5 upon 12 pi plus I sin 5 pi by 12. Put k is equal to 2. We get 4 to the 8 plus 1, 9 by 9 pi by 12 plus I sin 9 pi by 12. Now total 6 out of 6, 3 roots are different. We don't need the splitting, but after 3 we have to check whether the angle can be split into or not. Now put k is equal to 3 here. We get 4 3s are 12 plus 1 13 pi by 12 plus I sin 13 pi by 12. 13 pi by 12 can be split into pi plus pi by 12. This pi by 12, put this as it is here, and how many pi we have to add, just cross multiply. 12 into 1 plus 1 becomes 13. That's why it becomes pi plus pi by 12. Here also pi plus pi by 12. And we know cos of pi plus theta is minus cos theta. Sin of pi plus theta is minus sin theta. Take minus common. We get cos of pi by 12 plus I sin pi by 12. Same like this. x1. But it is just opposite. Minus x1. Okay. Now next. Put x k is equal to 4. Second last. Fourth root. Fifth root. It becomes cos of, put k is equal to 4, 4, 4 is the 16 plus 1, 17 pi by 12 plus I sin 17 pi by 12. Now split this angle, we get 12 pi by 12. Now 12 into 1 plus how many 17 is we need to make 17, that is 5. That's why pi plus 5 pi by 12 becomes 17 pi by 12. And these angles you can get it from earlier. 5 pi by 12 here completed. That's why next will be 5 pi by 12 here. And how many pi we need to add? Just cross multiply that. Okay. Therefore it becomes 12 plus 5 becomes 17 pi by 12. Pi plus 5 pi by 12. Pi plus 5 pi by 12. हा angle फक्त वरून शोधायचा. For this angle we get 5 pi by 12 from here. Next will be 5 pi by 12. After that 9 pi by 12 we have to add. Okay, in this way. These are the shortcuts. Now we know cos of pi plus theta is minus cos theta. Sin of pi plus theta is minus sin theta. Take minus common. We get cos 5 pi by 12 plus I sin 5 pi by 12. Same like this x2, but it is just negative. Okay. Now last sixth root, put k is equal to 5 here. We get 5 4 is 20 plus 1 21 pi by 12 plus I sin 21 pi upon 12. Now split this in remaining third is 9 pi by 12. Therefore 9 pi by 12 plus how many pi we have to add? Pi. 12 plus 9 becomes 21. That's why it must be pi plus 9 pi by 12 plus I sin 9 pi plus 9 pi by 12. Now cos of pi plus theta is minus cos theta. Sine of pi minus plus theta is minus sine theta. Okay, now take minus common, we get cos of 9 pi by 12 plus I sine 9 pi by 12, which is same as third root, but it is opposite in sign. These are total, these 3 roots same as the 3 root opposite in sign. We get these total 6 roots of this given equation. Okay, now let us start with the next. Here are some homeworks for you. Solve x raised to 7 plus x raised to 4 plus I into bracket x cube plus 1 is equal to 0. Hint is given. Take x raised to 4 common. We get x cube plus 1 as one bracket and x raised to 4 plus I as other bracket. X cube plus 1 is easy as solved earlier. X raised to plus I becomes x raised to 4 is equal to minus I. Right? X becomes minus I raised to 1 by 4. And for minus I, we need this. Minus I, for minus I put cos pi by 2 minus I sin pi by 2. The rest of all the terms are same. Okay. Just put middle sign minus for minus I. And go on solving the same by same method. You will get the how many maximum power of x is 7. We need 7 roots. Out of that, 4 root you will get from this equation and 3 root we will get from this equation. This equation we already solved. Copy that equation as it is. Now here also x raised to 9 plus x raised to 5 minus x raised to 4 minus 1 is equal to 0. Now here for I'll take x raised to 4. Here minus, take minus common. Here it is very easy. X raised to 5 you can take common and x raised to 4 plus 1. Here minus take common, x raised to 4 plus 1 is equal to 0. Again take x raised to 4 common and we get total 9 root you have to find. Okay. Now next, x raised to 10 plus 11 x raised to 5 plus 10 is equal to 0. Now here you have to split this middle term x raised to 5 into x raised to 5 plus 10 x raised to 5. 11 x raised to 5 becomes x raised to 5 plus 10 x raised to 5 to split to take the common terms. Okay, then we get x raised to 5 common, we get x raised to 5 plus 1, and here 10 get common, x raised to 5 plus 1. Now again x raised to 5 plus 1 is a common and x raised to 5 plus 10 is the other factor is equal to 0. Now for total 10 root you have to find, out of which 5 root you will get this from this equation which is like earlier, and 5 root we will get from this equation. In this equation this 10 is the extra thing only. How to solve this? Let us see. X raised to 5 plus 10 is equal to 0. X raised to 5 becomes minus 10. Now to split this minus 10 as minus 1 into 10. Okay, now take x raised to 5 to cancel this 5, take 1 upon 5 fifth root on both sides. We get x is equal to 10 raised to 1 by 5 and minus 1 raised to 1 by 5, and keep this 10 raised to 1 by 5 as it is till the end. Okay, and minus 1 raised to 1 by 5 how to solve we have already seen. Put minus 1 as cos pi plus I sin pi. Okay, and add 2k pi. Rest of the all steps are same for minus 1 raised to 1 by 5. Just keep this 10 raised to 1 by 5 because it is a constant as it is till the end of these steps. Okay, these are 5 roots, these are 5 roots, total 10 roots you will get from this equations. Okay, now this is one more homework. x raised to 6 plus 1 is equal to 0. Okay, total 6 roots you need to find. K values 0, 1, 2 up to 5. Here x raised to 9 plus 8 x raised to 6 plus x cube plus 8 is equal to 0. Hint is given. X raised to splitting this we get x raised to 6 plus 1 x cube plus 8. These are two factors here, and x raised to 6 plus 1 is like this only. This is the same equation. Just repeat this equation or just write down this as earlier. Okay, and x cube plus 8 can be solved like this. Here instead of 10, 8 is there only. Okay, x cube is equal to minus 8. Minus 8 can be split into minus 1 and 8, and take cube root, we get minus 1 raised to cube root, and 8 cube root is 2. Okay, here 10 raised to 1 by 5 we have to keep that as it is, because there is no any fifth uh, you can, this is a constant. Okay, you can keep this as it is till the end. You are not because the complex root of the complex number start theory start with this equation. We don't need to split this 10 because it is a constant. Okay, like this only. This 8 you know don't need to solve, because 8th cube root is we know 2. Okay, keep that 2 as it is till the end of the steps. And this minus 1 raised to 1 by 3 is the actual part of roots of the complex number. Okay, and that can be solved by earlier method. 3 root you will get from this, and 6 roots you will get from this. Total 6 plus 3, 9 roots you have to find. Okay, now let us see next. Example: if alpha square, alpha cube, alpha raised to 4 are roots of the equation x raised to 5 minus 1. Okay, this is the given thing, that is x raised to 5 minus 1 equal to 0. There are total 5 roots. Out of 5 roots, these are 4 roots are given. Okay, these are notations. Then show that 1 minus alpha square, 1 minus alpha cube, 1 minus alpha raised to 4. If these are the roots, then what are these called? These are the factors. Okay, the multiplication of all these things, we have to prove that it is 5. Okay, let us start. We have to first find out the roots of this equation. Start with this equation: x raised to 5 minus 1 is equal to 0. Then x raised to 5 is equal to 1. Then x is equal to raised to 1 by 5 on both sides. Put 1 as cos 0 plus I sin 0. The similar method, we have to find out the 5 root of this equation. Therefore x is equal to add 2k pi plus I sin 2k pi raised to 1 by 5. K start from 0, 1, 2 up to 1 number less than 5, that is 4. Total 5 numbers. 2k pi, take 1 by 5 inside to the angle by De Moivre's theorem. We get 2k pi plus 2k pi upon 5 plus I sin 2k pi upon 5. Now k values we have to put as first 0, that is first root. x1 is equal to cos 0 plus I sin 0, that is 1. 1 is the one root. That's why they are giving only 4 roots notation. Now put k is equal to 1. We get 2 pi by 5 plus I sin 2 pi by 5 alpha. Call it as first root, that is alpha. Now put k is equal to 2. We get 4 pi by 5 plus I sin 4 pi by 5. Again use the De Moivre's theorem here. Split this 4 as cos 2 pi by 5 plus I sin 2 pi by 5 raised to 2. By De Moivre's theorem, if you take 2 inside, you will get the same answer. 2 to the 4 pi by 5. Now this is again the earlier alpha. That's why it is alpha square. Second root we get. Okay. Now put k is equal to 3. We get cos 3 to the 6 pi upon 6 pi by 5 plus I sin 6 pi by 5 is equal to, again split this 6 pi by 5 as 2 pi by 5 raised to 3. 3 to the again we get 6. And this is again alpha, it is cube. Okay. Now next put k is equal to last fifth root, that is this is second, third, fourth, this is fifth. This is fifth root as cos 8 4 to the 8 pi by 5 plus I sin 8 pi by 5. Again split this 8 pi by 5 using De Moivre's theorem. 2 pi by 5 raised to this 4. 4 to the this, again we get the same answer. And this is again a alpha raised to 4. In this way we have find these 5 roots. Now we know if 1 alpha, alpha square, alpha cube, alpha raised to 4 are the roots of the equation x raised to 5 minus 1 equal to 0, then x is a variable x minus 1, x minus alpha square, x minus alpha cube, x minus alpha raised to 4 are the factors of this equation. Okay, like for example, suppose there is an equation, quadratic equation, x square plus 3x plus 2 is equal to 0. Okay, then how to factorize this? This 2 can be split into 2, 1. These are the roots of this equation. Okay, then how we write this equation as x minus this 2, this is x variable minus this 1 is equal to 0. Okay, that means if 2 and 1, 1 and 2 are the roots, then x minus 2 and x minus 1 are the roots of the equation, factors of the equation. Okay, here minus should be there, right? X minus, it is minus, right? Okay, this is the same. X square plus 3x plus 2 is equal to 0. Suppose this is a quadratic equation, then we know 2x plus 2, x plus 1 are the factors. And what are the roots? X is equal to minus 1, x is equal to minus 2, right? If these are the roots, then how we take the factors? As a subtraction from the variable. That is x minus of minus 1, right? And x minus of minus 2. It becomes x plus 2 and x plus 1. We take, if any number is the root of the equation, then x or that variable minus that number is called the factor. We take the opposite of that number. That's why if these 5 are roots of the equation, we have just find out, then x minus of each of this number or alphabets are the factors of this equation. Okay, now how can we write this factor? Then x raised to 5 minus 1 becomes multiplication of all these 5 factors. Call this equation number 1. Now what we have to do, x raised to 5 minus 1, we have to divide this this factor by this factor x minus 1 by actual division. We have already seen this division for m1, the division of x raised to 5 minus 1 by x minus 1. Okay, now put x raised to 4 here, we get x raised to 4 into x is x raised to 5 minus x raised to 4. Subtract this, we get x raised to 4 positive first minus 1 negative, negative later on. Now again x raised to 4 is less than x raised to x power, that's why again put plus x cube here, we get x cube into x is x raised to 4 minus x cube. Subtract, we get x cube, this plus this gets cancel, x cube minus 1. Again the index is much bigger than this, we get again x square here, x square into x is x cube here, and plus into minus 1, that is minus x square. Again subtraction, we get x square minus 1 remain. Again put 1 plus x here, we get x into x square plus x minus 1 minus x. Subtraction, we get this cancel, x plus 1. Here again x plus 1, here also x plus 1, plus 1, we need 1 extra, we get plus 1 as 1 into x minus 1 remains here, x minus 1, and remainder is 0. Now this is the actual division. Now how can we write this x raised to 5 minus 1 as this multiplication of these two, and remainder is 0. We don't need to write 0. That's why I write this expression here. Instead of x raised to 5, we get this factor here on LHS side, RHS side as it is. Okay, now x minus 1 cancel on both sides. We get this term is equal to multiplication of all these 4 brackets. Okay, now what we have to prove? This show that this bracket is equal to 5, and we have these brackets. Instead of x everywhere, we have this 1. Therefore at this stage, put, this is a variable, x is a variable, that's why put x is equal to 1 everywhere. We get 1 plus 1 plus 1 plus 1 plus 1 on LHS side. On RH side, 1 minus alpha, 1 minus alpha square, 1 minus alpha cube into 1 minus alpha raised to 4. Answer for this brackets are, multiplication of brackets are total 5. Okay, this is a bit little lengthy example.